excuse me, with section 5.4, complex numbers. A couple of things for review before we go on. Remember chapter 5, we are always looking for the place where the parabola crosses the x-axis, and there are 3 possible answers when that's what we're looking for. This first drawing, you have 2 real roots there, 2 real numbers, whatever they would be, maybe -1 and 2. And then this one crosses 1 time. That's a double root. So you only have 1 answer. It's an answer twice. And then over here, there are no solutions. That doesn't cross the x-axis anywhere. So I told you back in section 1 that later in the chapter we would cover imaginary numbers. And that's what we're doing today. You can still solve this parabola, even though it doesn't come in contact with the x-axis, you can still solve it using imaginary numbers. So that leads us into what we're talking about today. First, though, they're just simplifying square roots. Square root 50. Some of you may have seen this before, some may not. You always have to check a radical to make sure it is in simplest form. Make sure there are no perfect squares that go into that number in order for it to be in simplest form. So sometimes while you're solving these parabolas, you'll end up with a square root of a big number. And you have to determine whether it's simplified or not. So again, these first few examples don't have anything to do with imaginary numbers. It's leading you into simplifying radicals. So what you have to look for, are there any perfect squares that go into 50? Now, some of you probably already know what it is, and some of you have no idea what the perfect squares are. So if that's you, you'll probably need to write the perfect squares on top of your paper or in your notes somewhere so that you can see those very clearly each problem. So 2 squared is 4, 3 squared is 9, 16, 25, 36, 49, and so on down the line. Those are the perfect squares. So do any of those numbers go into 50? 25 goes into 50. So the way I have kids split that up is instead of writing 50, you write 25 times 2. That's the same as 50. You just split it up into a perfect square. So what is the square root of 25? 5. So you can actually do the square root of 25 and bring your 5 out front. What's left under the radical? 2. So your simplified answer there is 5 square root 2. You'll have to do that from now on. Anytime you have a radical in your answer, make sure it's in simplified form. Some teachers will teach it like this, where you do square root 25 times square root 2. You can do that as well. It doesn't matter to me how you split that up. And then the square root of 25 is 5, and that leaves square root 2. Either way you want to write that is fine. If you don't write that, it's fine. I'm not going to count off. If you go from here to your answer. Just again, every time you skip a step, there's more opportunity to make a mistake. So keep that in mind. Square root 11 over square root 49. And actually, they have it written as 1 radical, 1 fraction. Square root of 11 over 49. Anytime you have this, you're going to split that up and do the square root of 11 over the square root of 49. You can't ever, remember this, ever leave a radical in the bottom of a fraction. And we'll get to a method later to get rid of it. Right now it'll work out where you won't have one anyway, but you keep that in mind. Never leave a radical in the bottom of a fraction. So looking at the top there, the square root of 11, do any of these square roots go into 11? No, so that one is simplified. You can't do anything else to that. Sometimes there will be no numbers that will go into them. That means it's already simplified. And then what's the square root of 49 on the bottom? 7. So you end up with square root of 11 over 7. Questions over those? The next thing then is the imaginary number. If you were to type in square root of -1, you're welcome to do that on your calculator right now. That will give you an error. There is no square root of -1. You can't do the square root of a negative number anytime. And that's what happens on these problems up here, where it doesn't cross the x-axis. You'd end up with a square root of a negative number. That's what makes it an imaginary. So anytime you see a negative under the radical, you need to take out, you put an I out front. I represents the imaginary number. And anytime you put the I out front, it makes whatever's under the radical positive. So that's just a step you're going to do anytime you have a negative radical. We'll do a few of those problems just like the first two, only they'll be negative. So if you had the square root of -18, the first thing you need to do there is realize that's imaginary. There's no way you can solve that the way it is. So how do we make that positive? Put the I out front, and it's now I square root of 18. And then you simplify the square root of 18 just like we did in example 1, or those first two examples, I guess. So what is the square root of 18? Is 18 a perfect square? No, so we have to check, do any of those numbers go into 18? 9 does. So you can write that I square root 9 times 2. Don't forget the I outside. And then what's the square root of 9? 3. So when you bring the 3 out here, you multiply the 2. So your answer is 3I square root 2. So it's the same as the first examples, except you have an I in there so that we know it's an imaginary number. Square root of -27. Just for another one of those. What do we have to do first? Put the I out front. So we get positive 27. Is 27 a perfect square? What goes into it? 9 again. 9 times what? 3. So what's the square root of 9 again? So this time we have 3I square root 3. The next thing we'll need to cover, I's repeat in 4s. So if you have I equals the square root of -1. I is I. I to the first is obviously I. Just like x to the first is x. If you square I, or if you have an I squared in your problem, that equals -1. So any time that you would have an I squared in your problem, you would change that to -1. Again, never ever leave an I squared in your final answer. I to the third is -I, and I to the fourth is +1, and then from that point it starts repeating. So I to the fifth is going to be I. So that's the first one again. I to the sixth is going to be -1. I to the seventh is going to be -I. I to the eighth is going to be 1, and it starts repeating again. I to the ninth equals I. So what would I to the 10th be? -1. And we keep repeating again in 4. Every fourth one will be the same. So this next example, they want you to tell them what I to some big number is going to be, and they have I to the 45th. I to the 45th power. Which one of those four is it? Is it I, -1, negative I, or positive 1. Here's how you figure it out. You figure out the number lower than 45 that 4 goes into perfectly. Does 4 go perfectly into 45? Does 4 go perfectly into 44? Yes. So I to the 44th, how many is left over between 44 and 45? 1. So that is I to the first power. Or just I. You don't have to put I to the first power up there. So if we had I to the 38th power, does 4 go into 38? What? Does 4 go into 38? Excuse me. No. Does 4 go into 37? Does 4 go into 36? Yes, it goes into 36. So what's left? How many? Between 36 and 38, I squared, which is negative 1. But I to the 87. So we're going to 87. How are you going to figure these out each time? Especially if it's a big number and you don't know your multiples of 4. What do you need to do? Use your calculator and do what? 87 divided by 4. That doesn't work. 87 divided by 6. Does that work? I said that wrong. 86 divided by 4. Does that work? So 85 divided by 4. 84 divided by 4. Does that work? Yes. So how many do we have left between 84 and 87? So that would be I to the third. And what is I to the third? Negative I. So those first 4 you have to have memorized. If you end up with an I to the first, don't put the square root of negative 1. So basically I equals I. Whoops, not negative I. I equals I. So it goes I, negative 1, negative I, 1. I, negative 1, negative I, 1. That's how you remember it. Make sure you do. But those are the only 4 you need to have memorized, and then you can figure it out from there. We also have a couple of multiplication problems in that example. We're showing you that you will never leave an I squared in your final answer. So you're going to multiply the i's. You're going to multiply, add, subtract, and divide just like you would if they were x's. So if you had 2x times 4x right there, what would you get? 2 times 4 is 8, and x times x is x squared. So it's the same thing with the i's. They work the same as any other variable that you've ever used. So negative 2 times negative 7. It's not negative 7. I didn't figure it was. Times positive 7i. Negative 2 times positive 7 would be what? Negative 14 now. And then I times I is I squared. And what do we change that to? Negative 1. So basically you now have negative 14 times negative 1, which is positive 14. The I squared is the one you're going to see the most often. That's the one you have to memorize. That's the one you have to know. You never leave in the final answer. Always change that to negative 1. Down at the bottom of page 260, example 4. There are 2 ways to solve this problem. I will show you both, and I don't care which method you use. 3x squared plus 48 equals 0. So that is a problem just like we had last section in section 3, which was factoring. Now, what is the first step of factoring? Does anybody Remember what we always look for first. Common term. So is there a common number between 3x squared and 48 that we can take out? We can take a 3 out. Can we take an x out? 48 doesn't have one. So we take a 3 out. That's going to cancel. We're going to have x squared plus what? What? X squared plus 16 equals 0. Do we need to worry about the 3? No, we would just divide that off and it would be gone. So what you're basically left with is x squared plus 16 equals 0. So we need to solve for x. Remember, this is not difference of squares. Why is it not? Why is that not difference of squares? Because it's a plus sign in the middle. So we have this, and we've set the factor equal to 0, just like we did in section 3. Set all your factors equal to 0. And what would we do first then to solve for x? Subtract the 16. And now we have x squared. How would we get rid of that squared? Anybody know? Take the square root of both sides. So the square root and the squared cancels. Leaves us with just x. So we have to simplify the square root of 16. What do we have to, or negative 16, what do we have to do first in this problem? Take the I out front. So we would have I square root 16, and what is the square root of 16? So we would have 4i. There's nothing left under the radical because 16 is a perfect square. 4i would be your answer. You could have done this stuff in the first step. Instead of taking out the common term like we did right there, the other method then is just to start solving. So this is factoring. What we did right here, we factored out the 3. You don't have to in a problem like this where you've only got that one variable and it's squared. How could we start solving for x there? Just subtract the 48 over. So again, either way you want to solve that, it's fine. And then what would we do? So x squared equals negative 16 again, and I won't solve that again for you. But either way works there. There is one other rule that you must remember. I'll write it down. I would if I were you. Anytime you take the square root of both sides of an equation, like we just did, we took the square root here of both sides of the equation. Anytime you do that, it's always plus or minus. You always have to put a plus or minus in front of your answer. Because remember, you're always going to have two answers. You're either going to have two real numbers, you're either going to have one double root, so it has to count twice, or you're going to have these imaginary numbers. So all that means is when you take the square root of both sides, you got to have plus or minus right out here in front of your problem.